Hello and welcome back to the laboratory of Dr. John Pellegrino. My name is Paul Canny, and right now I'm going to take you through the technical aspects of our Nanoimprint Lithography machine and sort of show you how it does what it does. So first off, what makes our machine special is that we have X, Y, and Z motion control. Most of the Nanoimprint Lithography machines out there today can only do a single stamp area, but what's good about ours is we can take that silicon stamp that I showed you earlier and we can actually create an array of stamps. And so this broadens out that surface area and allows us to create that ultimate belt material that I showed you as well. So let me first take you through the XY motion control. What we have here are some NEMA 23 stepper motors coupled to a 1mm lead screw shaft. And what this does is actuates our table back and forth. These two are what holds our polymer material, and when you activate these stepper motors, it drives this table back and forth. So that's our X motion, pretty simple. And then for the Y motion, it's the same thing. If you can see that down there, we have another stepper motor coupled to a little bit longer 1mm lead shaft, which does the same thing of moving this box frame back and forth in the Y motion. So that's basically our X and Y motion in a nutshell. And now I'm going to take you through our Z motion. So what we have here is a house air that comes into a 5-way cylinder. Let me show you that there. That's actually, that's a 5-way valve, and what it does is when you apply a voltage to it, it reverses the polarity of the way that the air pressure is flowing. Both those air lines are plugged into this. This is a Bimba 3-stage pneumatic cylinder, and what this does is when you activate that 5-way valve, it'll push air into your cylinder and it'll drive your pressure head down. So that's how we accomplish our Z motion. It can give a push force of about 2,000 pounds at roughly 40 or 50 psi. So it's really strong and gets us up to the high pressures that we need in order to imprint our nano features. So that's basically our XYZ motion. Now let me take you through how we're actually going to accomplish getting high heat as well as the imprint pressure necessary. So what we have here is a heating head, and this has an embedded thermocouple resistance heater. If you can see that there, this little guy here. And what that does is it heats up as well as gives us temperature control. And this heating head has the capability to get up to about 300 degrees Celsius and anywhere in between. So that gives us a really nice heating control, which allows us to reach glass transition temperatures of our polymer materials. Additionally, this guy is our pressure head, and what this does is it gives us a nice even pressure. If you know a lot about fluids, you'll know that if you have high pressure within a fluid, it'll be a nice even pressure as opposed to if you're just stamping with two parallel plates. The way that this is accomplished is over here we have a high pressure nitrogen cylinder, which is then lined over to a 2-way valve, which allows us to inflate and deflate our pressure head. And what we're doing is we're actually, let me get you up onto there, we're actually using a Kapton thin polymer film right here as our pressure backing, and this flexible polymer film fills up with air sort of like a balloon or an airbag inflating, and it applies a nice even pressure to the silicon stamps during our stamping. So that's our technical aspects of our nil machine, and that's pretty much how we're getting our nano imprinted features.